What is a sum of two squares? Well, a sum of two squares is an expression such as a squared plus b squared. Let's call this expression number 1. Now, what if we have a plus b all squared? We know that this is equal to a plus b multiplied by a plus b, which is equal to a times a is a squared, a times b is a b, b times a is also a b, b times b is b squared. You can simplify this to a squared plus this and that is 2ab, then plus this b squared there. Now, what is the difference between this expression and this one here? Let's call this one number 2. There is an a squared and an a squared. There is a b squared and a b squared. So the only difference is a 2ab term there. So if I was to take this expression there and say a plus b all squared and subtract this minus 2ab, I would get this here, which is equal to a squared plus a squared plus 2ab plus b squared, then minus this 2ab here, so minus 2ab. Now look here, 2ab minus 2ab will give me nothing, so this cancels with that, and I am left with an a squared plus b squared. So that means if I take this expression here and subtract 2ab, I will get this expression here, expression number 1. So in other words, we can confidently say a squared plus b squared is equal to this one here, a plus b all squared minus 2ab. In mathematics, we actually write this not as an equal, but as we put an identity sign here. So a squared plus b squared is identical to a plus b squared minus 2ab. Identical means no matter what value a or b takes, what is on the left hand side is always equal to what is on the right hand side. Let's just repeat the process. We started off with a squared plus b squared and we called it expression number 1. Then we started playing around with this expression here, a plus b all squared, and then we expanded it. It's a plus b times a plus b, which boils down to that, and we call this expression number 2. Now, then we said, what's the difference between 1 and 2? The difference is that here we have a 2ab, which we don't have here. Our a squared is there and our b squared is there. So that means if I was to take this expression and subtract 2ab, I would get this one here, which boils down to just a squared plus b squared, which I have here. So therefore, a squared plus b squared must be equal to this one squared with a 2ab subtracted from it. So we ended up with an identity. A squared plus b squared is identical to a plus b all squared minus 2ab. How would we use this in practice? Supposing I was given an expression 50 squared plus 40 squared, and I'm required to evaluate it. I would say, okay, this looks like my sum of two squares, where my A is 50 and my B is 40. So I can use this identity here to say 50 squared plus 40 squared is equal to 50 plus 40, which I have here, all squared, minus 2 times A is 50. 2 times 50 multiplied by my B is 40. Okay, so 50 plus 40 is 90. So I have 90 squared minus 50 times 40 is 2,000 multiplied by 2 is 4,000. So 90 squared is equal to 8,100 minus my 4,000 there, which is equal to 4,100. If you enjoyed this video, please like, follow, and share. Till next time, bye-bye.